Oh well, give me a minute or two. I'm just waking up as well. Uh, I haven't got my lights on much at the moment. Yeah. Right, let me know when it's working, because I'm just waking up. I'll talk to you about all the carrying on I had last night. Well, this morning actually, whatever, and the results of all my efforts. uh, Put this light on a minute. I have to put this back in the thing because it's on its end right now, and it's kind of. Um. Alright. I didn't say it would stop it, I just said I hope it would stop it. My stream isn't showing up live yet. No, it's not showing me as live yet, just a minute. Well, it seems to be running live right now, but it's just a bit of there's a bit of a delay or something. My other live stream window, preview window is I haven't got the preview up yet anyway. Right, where's the preview window thing? I haven't got it on. I haven't got that thing running yet. I'm trying to find the damn button for it. Preview, where the heck is it? Oh, okay, it's the top menu, it's the top bar thing. Right, just give me a minute, I'm just waking up, bear in mind, I'm half asleep. Well, okay, I found that preview thing. Right. Right, we'll see if that sorts it out. trying to find the other chat right now. Where the heck is it? My other chat's not working, Alan, right now. I can't see anything. I've got a blank screen on my other chat right now. This is what I'm seeing. Oh, hang on a minute. Right, let me just switch to the... My other chat is blank right now. All I've got is a black box. My chat is just blank, so I can't see any chat there right now. Yeah, it just does that sometimes. There's a problem with it sometimes. Might be better if I just log out and log back in again and try again. Actually, give me a minute. I'm going to kill the stream and come back because there's a problem with the chat anyway. And obviously, when it does that, it might be because the server's down actually, because sometimes that happens. The live stream chat is on another server, and and it sometimes doesn't work. I don't know why. It might be because I'm an XP, and it just doesn't like negotiating protocols or something with me. I don't know, but yeah. Anyway, right, okay, well, there's good news anyway about the rebuild, reconfiguration yesterday. I put everything back the way it was, but except for the inner cores. The inner cores are the 3.5mm and 3 laminations per individual slot now, so there's actually more inner cores in there now, and I have got twice the output on the voltage. Yes, almost an entire volt now instead of half a volt, which is good because it proves that I was right, that I needed to change that material around. But in the process I went and knocked the end caps off because the glue broke, because I was having a struggle putting it back together again. So I'm going to put this back in there because I haven't put it back together properly yet. I'm going to put the frame that holds it. Let me put the camera back on. Oh yeah, well it's still flickering, I don't know why. I've got the flipping preview up as well and it's still not doing it. I think I might restart the stream in a minute. Just be patient with me. I didn't say it would stop that flickering, I just said I hoped it would. Okay, so I need to put my foam. Oh, where the heck is my foam actually? Yeah, that's disappeared now. Yeah, I've got these little bits of foam which I oh, there's one of them. Well, there's one piece. Right, where's the other one? I can't see the other piece. You know what? I'm probably going to have to use something else other than that foam. I'm probably... Everybody's having problems today with their connections. What microphone am I on? Oh, let me just double check my microphone volume as well. Oh, right, Alan. Well, I never noticed you there disappear, actually. You never logged out at my end. Well, that's strange when that happens. It often makes me wonder what the hell causes that, but sometimes our keyboards have got a power button on them and we accidentally press the wrong button. And it's annoying when that happens, you know. You're typing away and all of a sudden you realise you've just, instead of pressing an F key, you've pressed the power button on the keyboard and everything goes into standby. Yeah, I've done that before. You know, there's an F5 refresh button on my keyboard for the browser, and it's kind of well, it's 4 buttons actually off. The F8 key actually is directly below the power PC button on the keyboard. And if you ever hit the F8 key while you're running Windows and you miss and you hit the power PC button, it's sleepy time. You know. It's funny when that happens though, but you basically got to wait for it to go into standby, because if you try to come out of standby in the process of it going into standby, it can really screw things up. And I've done that before as well. Yeah, things have come back but not properly, and network connections have basically gone to sleep while the rest of the computer's walking back up again. Ah, that's fun. That is fun. I'm just thinking a minute. I'm just trying. Is it afternoon? I'm just waking up. Where the heck is my phone gone that I was using? Actually, I've got an idea. Instead of putting foam around these things, I'm going to put some rubber bands on. It might just make them a bit thicker so I can clamp them better. That's an idea. Rubber bands. Yeah, the rubber bands should just give me a little bit, because that foam tends to crush. It gets crushed quite easily. Let's just find something that's the right size. I have to put in the bracket, this bracket thing, right? Because it can fall over when it's done its end like this, and oh yeah, I finished this configuration for the moment. I'm going to connect it up and show you in a bit, but I'll switch it on in a bit. I'm just trying to put this back in here first. I don't like moving it around while it's on, because I can short wires out. I'm just looking for some thick rubber bands in here. Is that big enough? Excuse me. No, that band's a bit too small. That rubber band is just a little bit too tiny. Oh, I found a nice thick one. Is that one a bit narrow? I want thick rubber bands but small in diameter. That's one. Where's the other one? I've got some more of these. Just a minute. I'm sure I've got another one of these somewhere. double one up maybe. I don't know. See, you can't tell what's in this bag until you pull them all out. I don't like pulling them all out. Let me see. What's that one? That's thin and horrible. That's thin and horrible. It's just no good. I'll have to try doubling one of these up. That might work if I'm just basically looking for clamping rubber at the moment. Oh, hang on. Just be patient with me because I'm still waking up. I'm still on my first cup of coffee right now. We've had a lot of fireworks going off lately. We're getting close to the flipping fireworks night, you know, and there's these kids that keep letting them off prematurely, and I don't get a lot of sleep. I mean, sleeping early in the evening is not always a good idea with fireworks banging and exploding and popping and right. So I'm just going to improvise with these two thinner ones as well, if I can. Now, this thick one will probably help. Yes, that one's going to be nice tight. I wish I had two of these. I'm just putting a rubber tire on, basically, so that it doesn't slip out of them clamps, because these are a little bit smaller. These resin, yeah, well, it's Halloween. Well, we have Guy Fawkes in the UK. It's not the same thing, but we also have that Halloween crap as well. But Guy Fawkes is Bonfire Night, which is the 5th of November, which is, hang on, it's actually in 3 days. Well, so that's when it gets really, really noisy, and it's a celebration of, apparently, of when Guy Fawkes was caught trying to blow up the Houses of Parliament back in way back. I've forgotten the date now. But it's a completely different celebration to Halloween, and that is our reason for fireworks. I don't know if you can see, but I lowered the camera a bit actually, but I'll try and raise it back up again. Give a bit better bird's eye view if I can. Right, if I can get this back in now. I want to put it back in right the same way up. I've got metal stuck to the bottom at the moment. I had to stick it on a plate of metal because it kept falling over. I put the configuration, the iron cores back the way they were before. On the ends, that is. But I noticed immediately that there was a different tuning, so there's actually less iron inserts in there than there was previously, which is good. I need to disconnect these wires while I put this in. Right. One of these is I'm gonna have to. The wires are gonna have to go. I'm gonna have to take these brackets completely off so the wires are in the middle. Just a minute. I can't do this. Oh, Hyde's there. Hello, Hyde. Oh, damn it. Oh, I can't get this off. Not without unscrewing it completely. It's just that I've got to wire it up now. I'm not going to wire it also. Alright, okay. Right, I'll just get this back in there if I can. I haven't got the other rubber on yet, but I'm going to do that in a minute. Now that rubber band I put on here is nice. It's a snug fit. Can I get this one on the other one? I'll stick that through there a minute. Maybe it's going to be big enough actually. The problem with stretching the rubber bands is the more you stretch them, the thinner they get. So I don't think stretching it is going to be the answer. So I'm just going to try and seat the rubber band around there. And see whether or not I can take some slack up somewhere along here, but I don't know. Yeah, I'm just going to... Oh, I see, this isn't glued on, it's just come off again. I'm just going to have to glue that back on again in a minute. I'll stick this over here on there. The rubber's just to stop it sliding in and out of the clamps, because these resin molds that I made, casts that I made out of my molds, they're just a little bit too small for the clamps. See if I can push that rubber in a bit. Right. I'll get that wedged in there. Yeah, I think so. That was not quite in. Okay, how's it in now? I'll have to get some bigger rubber bands, that's for sure. It also helps. The rubber band is very good at insulating against high frequency noise as well. Because I do get, it does generate quite a bit of noise. I've got this upside down actually, because the secondary wire is at the top now. Oh bugger it, I'm not moving it now. At least my wire access is at the top. I think it's just 180 degrees. This was over on the right before. I could just turn the whole thing around anyway. Just I'm used to where the wires are, that's all. Yeah, the trouble with using that foamy stuff was when I clamped down on it, it would collapse. The foam would collapse under the pressure, and then it would get loose again. But the rubber bands probably are a lot better. They shouldn't be compressed as easily. Right, now have I got this rubber band in properly? Well, just about, if I move that bracket out a bit. I'm stuck now. Right, get my brass washers on. Oh, there's actually 2 washers on. Yeah. Yeah, I was dog tired when I finished doing this, and I'm not putting it back together on the stand yet. I tested it quickly just to make sure it was working still, and I thought, oh god, it's a lot better. And it was. And then I went and crashed out. Right, I've got that back on there now. That's a relief. Bloody thing kept falling over. I was trying to balance it on its end because these weren't gluing on. I have to glue these back on properly. They're just decorative, actually, these silver things. It's mainly to protect the ends of the bobbin so I don't chip the ends off when I turn it around, move it around. They give a bit of protection. These chrome things are actually off bathroom fittings. I don't know if you can actually see that. I can't even tell on my camera if you can see that or not. Well, not properly. The chrome things on the ends are just bathroom fixtures off a plumbing thing. Well, somebody took them out and I thought, oh, they'd be handy. I thought they'd make nice bezels, you know, if you know what bezel is. So I stuck them on the end. I thought that helps protect the. They're actually, I think they're plastic, but coated with some kind of aluminium or something, because they're conductive, but they don't actually. They're not magnetic, so they must be aluminium. And silver things. But anyway, it gives a bit of protection from knocking the ends. Right, so I put the magnets back the way to bias them, I shouldn't need to do it. I have got a little bit of air gaps now between the end laminations, these laminations here and the end. I have a very small air gap on each end underneath the heat shrink sleeving. I think it's only like a millimetre to about a millimetre to 2 millimetres. Actually, it's a tiny little air gap. It's not big. And when I build the next one, I want to be able to make it so that I can adjust it more easily with an air gap. But yeah. Anyway, it was such a pain to put this thing back together again because of the it kept getting fouled up on something. So it was I had to make a couple of attempts because I had to take the damn cars out again, and then I had to file it a bit more, but I got there in the end. This is a secondary. Oops, I dropped my wire again. Just wiring up the secondary. Actually, I'll put it there. But the good news is, I was saying I was hoping to get maybe a volt. I said the other day, maybe I could even get a volt out of it. Well, actually, I almost have. I'm getting 0.9, was it 0.93 something? Almost a volt. Yeah, I've doubled my output because it was about half a volt before, wasn't it? It was in between sort of half a volt peak to about 0.455 or something. So I was getting around there, but now it's 0.9 something. I need to turn the power on for your oscilloscope as well. Right, turn the juice on. Okay, put this on DC volts. There's the meter. AC. Don't know if you can see it. That's what we're getting right now. We're actually a lot better than we were. We were on 0.5 something before. Now we're on we're actually at 0.890 right now. I've just moved it into a different position as well. I'll probably need to tweak it a bit. I'm just going to let this thing just to see if it is stable. I'm getting some interesting scope readings right now. Very curious scope readings right now. I'm not quite sure what's going on there right now. It's kind of odd. It looks like it's doing a dance. Ooh. Now let me just bring the camera over. Turn the light off so you can see it. But if we get that lined up, yeah, it's doing a rather curious little. I think I've got my phases slightly out of sync. Yeah, as I was tired yesterday. I was really tired, and I basically just plugged it in to test it quickly, and I twiddled some knobs and fiddled about to see if it was still at the same frequency, and I got 0.9 volts. But it wants resetting again. Actually, I need to tune it again. Right, the meter. Put the light back on. You can't see very well without the light. But glares and everything out. I'm trying to get the meter on as well, so you can see the voltmeter. Just a minute. I need to tilt that back a bit. I don't know if you can see the voltmeter. Tell me if you can see it. Alright, because I can't tell. It's very small. We need to get that on because I want to tune it a bit. Well, I'm just gonna see how it goes for this weird effect, because it was doing that before I went to bed actually. I thought, oh, that's interesting, that's cool, I'll leave it like that for now. And I went to bed, and it is very stable because it's remembered. It's actually remembered. So yeah, we're up 8.9. We're 0.892 right now AC, and I dare say, because we're over half a volt, which is really good, there's a high probability that I'll be able to get some DC out of it, because let's face it, I mean, if you're below about the voltage drop of a diode, you can't put it through a bridge rectifier, but I think those diodes, those bridge rectifiers I've got, I think they're Schottky bridge rectifiers, so we should be alright. I am going to try though, because these meters aren't very accurate. They are not very accurate at measuring voltage at high frequencies through a meter that's designed to really register something like 50 Hertz or something. But these frequencies are a lot higher than 50 Hertz, so I have got my multiple bridge rectifiers across there which I can connect to. I want to actually connect these up and see what we're getting. So what I'm going to do, my bridge rectifiers are here, connected to an analog DC meter, right? Can't get it on the camera now. Right, analog DC meter. So I'm going to connect my bridge rectifiers, which are stuck on blue tack, to this thing, so they don't float about. So I'm going to stick it through there and see if we actually get any what DC voltage we can see, because I am very curious. So I'll get this file out of the way. I'll stick this DC analog meter on the deck. I'll tell you what, this is so much easier than when I was working with the trying to get the pulse generator thing, the rotary discs thing. This is so much easier than that because I don't have to mess around with rotors. Right, I'm just oh, hi there. I don't know if you, I'll have to check to see what if you're actually watching as well, because I don't know if you're watching or not. I've got crap all stuff. I've got hairs and stuff stuck to my blue tap, and my bin's just fallen over. Damn it! Good thing that it's emptied. I would have had muck everywhere. Right, okay, just bear with me. DC voltage gives me all the peak voltages in a DC environment. Well, it's useful to check it. So currently I've got AC, and like I said before, it was below half a volt before. It was a little bit difficult to measure it. So now I should be able to put the DC through my bridge rectifier and see what actual DC output I've got coming out. Okay, Hyde. Right. I've got a bit rusty actually. I need to remember what the terminals are on here. I really need to solder some wires on here, because I haven't soldered any wires on these bridge rectifiers. Yeah, I think I need to solder some wires on, because I'm so sick of trying to connect stuff to it with the clips. Right, and let me just find some wires. I'm just going to solder a pink wire and a white wire for the AC input onto this board. I'm going to get my little piece of metal. Oops, oh, sorry, I've just knocked the camera now. No, I have no idea. Alan, who the other 6 or more viewer fans are. I think it's because it's linked to Facebook. You see, my live stream is sort of linked to Facebook. It's associated with Facebook, right? So if I post a link to one of my videos on live stream on Facebook, then anybody that watches that video can connect using their Facebook account and can thumbs me up or things, or like me or whatever, and it basically doesn't tell you the names very well. I think it did that with you actually. But it has to know who you are if you have an account before it can actually give a name or anything. And the others could be anonymous. They might have liked me but without actually signing in or something. So I don't know either. I don't even know who they are. As long as you're not the... Well, you're not Man in Black, are you? A guy came on Z's channel the other day and started going on about he was trying to impersonate Schubas or something, or people assumed he was Schubas, and he started saying, well, stuff that Z couldn't be trusted and all this, and I thought, oh, the fuck is this guy, sort of thing. And we thought, I knew it wasn't Schubas, me, but everyone else was thinking it was Schubas. And I said, no, there's no way Schubas would say things like that, because, and he was starting saying stuff and getting me paranoid, say, oh, you can't trust Z, you can't trust him, blah, blah, blah. Yeah, it was just crazy. And it's these anonymous people. It is these flipping anonymous people that come in as guest 1 or guest 2. I honestly think that Z needs to clamp down on that, because he needs to know who these people are. I mean, okay, he wants to keep it open, right, to everybody, but you're basically inviting trouble. You're actually inviting trouble when you don't require somebody to have at least some kind of a login. I mean, if somebody logged in with a Facebook account, that would at least give you an idea who they were. But when any Tom, Dick or Harry can go and just basically drop in, they can say anything they want and get away with it, because there's no way of finding out who they are, because a lot of people are actually protected by their internet service providers. Privacy policy bullshit and all that, and so you can get attacked and blamed and all sorts, and you don't know who it is. I don't know if you can actually hear the sound from it, because I'm not exactly on the same frequency as I was on before. I like to record it on audio sometimes using the 2 microphones and actually analyse the waveforms coming into the stereo, because I could record it as an audio file actually. The scope signal. Yeah, well, that's as long as yeah, but the IP doesn't mean a damn thing. You see, the IP address in the UK, we don't have a static IP address, right? Nobody unless you're with a certain business IP, internet provider. Most ordinary folk don't have a static IP address. They have what's called, I forget what the name is actually, but they're using a dynamic DNS. So you could have 10 people using the same IP address at any one time, right? And if I shut my router down and reboot my router, I'll get a new IP address just like that. Yeah, dynamic IP. So, IPs don't help you at all because you can't write an IP address down regarding a UK citizen and say I've got this person's IP address, because that IP address might not have been that person's IP address. It might have only been their IP address one day, and then the rest of the time it's being used by somebody else. So in the UK, the US, a few years ago, we had this issue on a website called lightworkers.org, and people were writing down people's IP addresses. And I said to them, you're wasting your time. You're wasting your time writing somebody's IP address down, because if they're in the UK, that IP address might have been used by them once, right? So you could get another guy, somebody else completely new to this website, who's never been on it before, who actually uses the same IP address of somebody that you banned. And that is not, you're going to basically accuse them, because they've got the same IP, of being a troll or somebody that came in and caused you a lot of trouble. And then they've got nothing to do with it. It's not their fault. They've just been assigned a new IP address that used to belong to a troll, and you're banning them based on that. And I told them this, and they were stupid. They just said, "Oh no, I don't believe that. If you've got an IP address, that's your IP address for life." I said, "No, it isn't." I've tried to explain to them, and they were just idiots. And they even banned me once because somebody caused trouble, and they'd actually had my IP address, right? And then a few months later, I came on completely unknowing that they'd even banned me. And I was on the chat and I was talking to somebody, and they said, "How comes you're here?" I said, "What do you mean, how comes I'm here?" I said, Why wouldn't I've just been busy, I haven't had a chance to come on." They said, "Yeah, but you've been banned." I said, "What do you mean I've been banned?" I said, "You didn't ban me, have you?" I said, "Yeah, you were banned for about 2 months ago." I said, "Well, I wasn't here when you banned me. Who was it you banned?" It causes such a lot of trouble. It really causes such a lot of trouble, People get banned for no reason. The only people who have static IP addresses in the UK are businesses. Yeah, they're just static IPs, are not just. They might be common in the US, but in some countries they might be static. You might have a static, but it's these days they're just roaming. I think they call it roaming, don't they? Something. Anyway, you could be on a mobile network. You could be on a hotspot connection. You could be in various. Static IPs just aren't. You can't use them anymore. They're just not reliable anymore. Right, I need to get my soldering iron on. I'm going to solder these wires. Shouldn't take long to warm that up. Oh, I want to turn my light off because it'll trip my cutout for the soldering iron. I'll just turn my light off for a minute or two while I warm this soldering iron up. I'm on the solar battery, and my voltage is a bit low at the moment. It's reading 10.8 volts. If it drops any lower, it'll trip my inverter trips off. Yeah, there is a shortage of IP4 addresses. Yeah, I agree. Right, come on, soldering iron, hurry and warm up. Right, I basically stuck this thing on a piece of metal just to stop it from sliding around because it's a bit heavier than metal, so I can solder the wires onto it without it moving around on me. You know, I've had this meter, the analog meter I've shown you on the camera earlier. I've had it like since the 80s. I've had it forever, but I probably got it 85 or 86 or something, and the plastic on it is deteriorating. It's just falling to pieces. I had to use a cable tie to hold it back on because the plastic where the screw went was just crumbling away. It still works though. Yeah, but IPv4, I don't know. I mean, there are still some devices that use that. I mean, I've still got some old computers. I've got a computer in the cupboard that uses is Windows 95. Well, I don't even know if it boots anymore. Right, I'm just going to put my other light on. Right, I'll just see if the solder iron's melt in, whatever. I'm going to get some wires soldered on here. Actually, I can stick the wires in them holes. I need to trim this wire up, clean it up a bit. So I'll move the camera across to where I am. Is this in the shot? Yeah. Right, I'm just going to solder some wires onto this board. Just trim the wire back. I don't really believe in upgrades. The trouble is the modern software is actually, in my mind, is even more exploitable, because you've got backdoors built in by Microsoft, deliberately put there so that they can hack into you. Well, that's why Microsoft has been patching backdoors and things since its first inception, because they were the ones that put the damn backdoors in the first place for their own use. And then the hackers find the backdoors, so Microsoft, in its innocence or pretense, comes out and says, "Oh, we found a leak. We found a security vulnerability in Windows. You need to install the security patch to plug the hole, basically." So you install the security patch, but at the same time, it's also creating a new one so that they can still have access. Microsoft has been doing that since day one. And then about another 2 years later, the new security vulnerability that Microsoft put there for themselves to be able to get into your system has been rediscovered by another hacker. Why do you think there's so many holes and security vulnerabilities in Windows? It's not there by accident. It's there because they put it there. But they won't tell you that. When you sign these agreements, what you're basically doing is giving them consent, permission to gather information about your usage of your computer. You're basically allowing them access. You have to sign these agreements, and you'll often find that if you don't click on the "Yes, I agree" button, you won't have access to their services. So you've got no choice but to. They're immune, so you can't sue them later on and say, "Oh, you put a backdoor into the Windows operating system," because they'll say, "Well, you signed our user at EULA agreement. You agreed that we could we could gather information about your usage of your computer. So they're covered, you see, legally. They're actually covered. So right, I've got them wires in the hole. I've pushed them in through the back. I just need to put my light on and hopefully my soldering iron will stay on long enough to solder this. And I'll put my light back on again. Hang on. Right, please don't cut out on me. Soldering iron. I made this board like 3-4 years ago. I used a load of surface mount bridge rectifiers. Each one of these bridge rectifiers can handle 500 milliamps. Oh, it's about half an amp, but it's rated at something like what is it, 1,000 volts or something. I don't know. They were actually for these solar LED lights, believe it or not. They were cheap, so I thought, well, I don't like surface mount, but bridge rectifiers, just for the sake of bridge rectifiers, having plenty of them, I don't mind spending a little bit for those, because I can get them all on a tiny board, and I have an array of bridge rectifiers for different coils, which is the idea. Right, that's soldered, so I can put my AC into these white and pink wires. Oh, actually I better twist them so that they look a bit tidier. It won't look so messy. Oh, this blue tack's not sticking right. Right, okay, board is on there. Oh, damn it, it's come off again. Doesn't want to stick on this steel for some reason. Maybe it's because it's waxy, I don't know. Hang on, I'm just going to degrease this piece of steel with some acetone. Where's my acetone gone? What the hell have I put that? Oh, here it is. I use my isopropyl alcohol because it's just not sticking. Right. It should stick to that now. I hope. Oh, it's stuck now. I can lift the damn thing up. I'm going to turn my soldering iron off. I want to see some DC output on that meter. Well, what's the matter? Is somebody arguing? I don't know. Yeah, it's Big Brother basically. It's all Big Brother. All this IPv stuff comes from top level. Anyway, right, I need to connect some leads to this AC onto these wires. I'll find some leads somewhere. I've got one wire. That's one wire. I need another one. See if I can find one. Oh, damn it, it's come off the bloody thing. It doesn't want to stick this within steel. It just does not want to stick. I'm going to find a bigger piece of blue tack. Hang on. Right. It doesn't want to stick for some reason. I'm going to stick a bigger piece of blue tack at the back because it keeps moving. Stay. Bloody thing, stay. You mean from me, Joy and all that? I found the other lead, right. Now, the AC leads are currently going down to this meter, so I'm going to clip on this lead. Now we should see, have I actually got the DC meter on the camera? No, not very well. I'll see if I can get this analog meter. The light's too bright. I'll turn the light off. Oh, okay, you should be able to see the meter better. Oh, it's still whited out. White backgrounds are hard to film. Okay, I'm going to try and pop that up. Stick that with a rubber underneath it. No, it's too... Damn it. I'll have to turn the... tell you what, I'll turn the meter around the other way. Just a minute. So as it's the right way around for you, I'm going to have to... you can see better. Ah, yes, you can see that alright. Hopefully. Now where's my other lead? I can see it anyway. It's upside down for me, but oh well. We're doing a video, so right, I'll just click this other wire on. Click this onto the other. We should see something on here. We should see some movement. Yes, it is moving. I'll stick this on the... hang on. I'll stick this on the... what? Hang on. What range am I on? I'll stick this on 2.5 volt. Am I on AC or DC? I'm on DC, that's right. Right, it's on the 2.5 volt DC range now, which basically means full scale deflection would be 2.5 volts. Well, it's nowhere near that, obviously. But at least we're getting something, which is better than nothing, because technically speaking, it means that we could run we could actually, if we have enough current, we could run a what do you call it, what do you call them flipping things? Stealer things? I can't think of what they call those damn silly circuits with one transistor and a flipping coil and yeah. I just can't think of them right now. My brain is gone mushy. It's what's it? A lens stealer, flux stealer. I can't think of the flipping word. It's a new name somebody's recently given these circuits that you can run any battery, any LED off a tiny battery or something. I can't think of it. Anyway, at least what? So it's topped out at about what? Hang on, it's upside down to me. About dual feed, that's it. Yeah, that's what I was trying to think of. Well, basically this is only sticking out 0.7 volts DC, which is still not enough really for anything other than a dual feed. And the current really is not really that good right now. Yeah, I don't know why they call it a jewel thief. To me, that implies that you're stealing somebody's jewellery. It's such a stupid name. Mm. I could understand a name like What Thief or What Thief. That would be more funny, wouldn't it? What Thief? What Thief? You know, What Thief? I don't know what thief you're talking about. Yeah, it would be better that way, it would be more fun. But jewel, I just don't get it. Yeah, I know there's powers measured in joules and all that stuff, but yeah, but most people don't know that. It's just a really technical name, and most people can't even spell electricity. Never mind joules. Right. Okay, so we know that the actual DC on there is very pathetic right now. Let me stick the AC meter over here on current, and I'll just bring that down. Let's see what that should disappear when I short this out on the load. Right, currently I'm only getting about 10 milliamps out on the AC, so that's going to short out. That's disappearing now on there. But it's not tuned up yet anyway. Now I'm going to stick this back on this other meter I'm using, back onto AC volts again, so that should start going back up again. So we're back at 0.894, and I want to see if I can tune this up a bit. So I really need to. No, we're not going to see any miracles today, by the way. We're not going to see any eureka moments today, because this, like I said, this device is a prototype, and it's not. I don't expect to get a lot out of it. Oh, yeah, there is something I found worth knowing, or you might find interesting. You remember the previous test that I did? I don't know if you were here actually when I did it, but you know when I shorted the actual output out, and I was measuring how much current was going into the circuit, and the only difference I was getting when I shorted the output on the secondary on the input, the only difference on the input I was getting was like 100 microamps. That's 0.1 of a milliamp. Well, do you remember that? And I was doing that at 0.5 volts AC, right? Do you remember that? Well, I'm getting the same thing now. When I short this out, I'm still only seeing 0.1 of a milliamp. No, on the input, the amount of change on the input was 0.1 of a milliamp, which is 100 microamps. Oh, well, you maybe weren't here. I don't think you were here for that test, but I think Hyde was here. I think it was Hyde I'm thinking about. Basically, the point of this device is to test the decoupling, the lack of effect on the input side when I'm actually loading the secondary down. But all I'm actually seeing on the input side is a change of 100 microamps, right, when I short out the output. So I was basically drawing, I was shorting out like 10 milliamps, or was it 22 milliamps at the time? But I was shorting out 22 milliamps at half a volt AC on the secondary, and the input only went up by 100 microamps. Yeah, that 20-second delay is bad. Yeah, sorry about that. So I'm getting exactly the same thing on here. So let me just try to show that. Let me get my other meter. Right, my DC meter. This is on 100 milliamp. This is set to 200 milliamp range. This is my I'm going to have to stick it on top of this analog meter, right? Just a minute. Now it's on 100. I'm going to put this in series. Oh shit, have I got enough leads now? Just a minute. I need to put this in series with the input to the circuit. You have to subtract the actual power consumed by the circuit and see the amount of power being actually going to the coil. So I'm going to be switching the coils off when we do that. I just need to find another lead. Just a minute. Oh. I've got another lead flying around. Oh yeah, here we go. Found one. Oh, stupid thing stuck to my rotors over here. Right. Right, I'm going to stick my meter in series with the power input. Now the black meter is going to be showing power going into the circuit board. Right? That is what the circuit board is consuming right now. Right? Now I turn the coils off. The noise should have stopped. Now that is the power being consumed by the circuit board, right, without the coils being turned on. That is what the scope is showing right now, which is basically it's not going anywhere. When I turn the coils on, you see the full waveform, which is when it's energized. Coils off. When the coils are off, that is how much power the circuit board is using. Coils on. Right, 45.8 right now. So with the coils off, you need to write this number down. 36.6 milliamps. You have to write that number down because you have to subtract that number from 45 point, well, call it 46, 45.9 milliamps, right? So write 45.9 milliamps and subtract the previous number from that number. Now I'm going to short out. Now I'm going to put my other meter, this meter, onto the current setting. So I'm going to move this, put this onto current, so it's on the 400 milliamp AC range. I'm going to put this probe into the milliamp socket. Now watch what happens on the input. Right, it's in the socket now. Now see what happens on the input. We're shorting out 9.5 milliamps right now. It's upside down, sorry. We're actually drawing out 9.5 milliamps on 400 milliamp range. We're in the current milliamp socket. Now watch the meter when I unplug it. I've just unplugged it. There's no change actually. He's not even showing a change right now. Right, I'll plug it back into the milliamp. Back in the milliamp. We're still seeing the same output right now, but there was 100 microamps change before, but now I'm not seeing that. Hang on, 45 point, it's hovering, you see, between 45.7, no, 45 point, oh, it's jumping around. Right, I've just unplugged that current load again. Right, unplugged. That should go up to 46, but it's not right now. But anyway, that's the point. The circuit, this design is not consuming, showing any change on input when I short the output. That is the point of this circuit. Right, I'll stick this back on AC volts now. We're back on the AC volts, 0.883. It needs to be tuned anyway. I need to get it tuned more a bit. Okay. Yeah, because when you subtract 36.6 or 45.8, that is the difference. That is the amount of power that's actually going into the coil, right? So when I turn the coil off, you can calculate exactly how much power is being dissipated by the actuation coils. I think it's around 9 milliamps or something, somewhere around about there. Yeah, I know. I know. Well, it normally doesn't do that, but it's because I'm moving the meter around with my hand, and the leads are a little bit funny. As you know, some of these Chinese leads, you get the crimps and that, and they're not very. When you start moving things around in your hands, you start to see deviations and things, but it is very small amount. That's the point. Right, I need to start tuning this circuit a bit better. So I'm going to try and set this meter up. I don't know if I can get this meter so you can see it when it's over here. Just a minute, let me move this. I can maybe get it under the scope. Maybe. Hang on. I don't know if you can see the black meter underneath. Oh, stupid lamp. Right, I'm going to point this back at the oscilloscope. I put the current consumption meter underneath the oscilloscope. I'm trying to get this position, this camera. It's difficult because it's on a swivel neck. I mean, the camera's on a swivel neck, but I can only get it flipping down. No, you can't see this meter, can you? It's on its side, so there's not much room to put things. Hang on. Stupid thing. Right. No, you can't see that. Damn it. Right, this is AC output, the white one. The black one is power going into the circuit, the total circuit. I'm going to try and tune this up a bit. I need to get it back to 0.9 volts on there. Right, I'm twiddling now. I'm going down in frequency right now. I'm going back up again. I need to adjust the duty cycle a bit. I'm aiming to get this back up to 0.9 once I had it earlier. I might be stretching it though, because I've got that meter in series with the power at the moment. Right, I'm going to just, that's the low frequency duty cycle. Now I'm going to go for the high frequency duty cycle. Doesn't like that very much. Going down. I might not be able to get it to the 0.9 without metering stage, because there's a bit of a drop across it, but I'm going to try. I need to adjust the high frequency as well. Just the high frequency in just a minute. Now, I don't think I can get it to that with that metering series, because there's a bit of a drop across it as well. Oh, are you up, Alan? Yeah, I got it. Add it up to 0.884. Yeah, which is pretty close. Okay, Alan. Right, Alan. Well, I'll see you a bit later. Anyway, I've still got lots of tweaking and tuning. But look at the output on the DC right now. It's actually gone up a bit. So on this analog meter. Oh, you can't see it right now. The analog meter is reading more than it was. I don't know if you can see that. So it's actually up to about was it on the 2.5 range? It's about 0.8 or something. 0.5, 6, 7, 8. I think it's about about 0.8. So that's actually gone up. That's kind of good. Yeah, it's almost time for my second cup of coffee right now as well. Yeah, I've still got some tweaking and tuning to do. Oh, look at that, we're at 0.916 now. Let's turn the coil off a minute. But that uses a bit more power on the input though, that's the only thing. So the actual input has gone up to 55.2 milliamps. So that is not an ideal situation when you're drawing more current. .2 on the input, which is down here. It's about balance between input power and output voltage. Well, output power as well, really. I'm happy with 43.6 milliamps, around about there, really. We're at 0.814 volts DC coming out, and we're using 43.8 milliamps on the DC input right now. And we've got a bit of oscillation. I'll see if I can stabilise that. Yeah. It's just a trigger point, I think, mainly. My actual DC output on this other meter, the analog meter, has actually gone down though. Interesting. Anyway, I'm gonna go and make some more coffee. Still, I think that's encouraging results. I think the fact that we're now double what I was the other day is, and the fact that when I load the output down, we see no significant change on the input is, to me, proves, well, it's a proof of concept to me, because that is the whole objective, is to actually get power out without seeing a change on the input side, and I am seeing very, very, very little change on the input side. It's negligible, a bubble. Anyway, I'm going to make coffee. Are you still there, Hyde? Sorry, I'm miles away. Mm. Um, I'm looking for my close peg. Mm. I'm just had a thought, maybe I can hang the meter with my close peg off the back of here. If I get my close peg and I clip it on the back like this, no, this doesn't work. It's really just a question of having places to put things in here. Well, it might work if I sew it on the back to hold it out like that. If I put something on the back, it would hold it. Nah, I give up. That doesn't really work. Yeah. Anyway, this is only measuring input power with that anyway, so. Oh, everything's falling off. Now, if I take the meter back out of line, that might actually go up a bit because it does seem to drop power a little bit. So if I disconnect it, come up you bugger. I'll reconnect it directly. It'll probably be a bit higher. Yeah, it is a little bit higher, which just shows that there's a drop when you put the meter on it. I really need to set this up properly, actually, but I need to build a proper well, when we start to get some decent voltages, I'll be able to use my when we get some decent voltage, I'll be able to use my, what you call it, power analyzers. And if I'm using this other camera, we can focus actually, we can focus it to actually show power analyzer readouts, because that other camera went blurry. That's the reason, part of the reason why I decided to try this camera. I didn't like using, don't like using webcams, to be honest, because of all the spyware and all the crap and everything else. But if I ever restore my computer from a backup, all of that stuff's going to be gone anyway, so I'm not too worried. But it would mean reinstalling the camera, obviously, if I needed it. But so basically, having this other camera means that I can adjust the focus, so it means it's going to be easier to see the power analyzer when I eventually have a voltage decent enough. I mean, at the moment it's just not practical, but yeah, actually I could put the I could actually do a power analyzer thing, but the problem is the board is consuming so much power right now. It's consuming like 43 milliamps, and that's just the board itself for the circuit. If I had a more efficient circuit, then there might be a way though of actually measuring just the coil, the amount of power going through the coil to the actuator coils, to the actuator coils and comparing that directly with the amount of power coming out. But as I say, we're barely touching half a volt coming out right now, and it's just not. Yeah, it's not practical. It's not easy to measure something so small. Even my DC meters don't. I mean, even those showing 100 microamps, it's so small, it's not going to register. I mean, we'd have to run a test for a whole week to get a significant result. That's what I'm saying. Because I looked at that power analyzer that I bought from China, and apparently it's in increments of 10 milliamps or something. Oh no, maybe it's in increments of 100 milliamps or something. Anyway, the bloody thing is just not. It doesn't have enough decimal places to be able to analyze power when it's a fractional amount of like 100 microamps. It just isn't going to work, you know. So you could put a load on the output, and the actual power analyzer wouldn't even see a change unless it was more than 100 milliamps. That's the problem. So it wouldn't register that. It wouldn't register 100 microamps, that's for sure. Unless it was on that very tipping point of just tripping over that point, that threshold. And I'm not going to start fighting about with that. Oh, no way. It's just not worth it. I need to get the new version built, and I know some other additional improvements I can actually make to the new design, which I'm going to try and implement before I actually get the 3D prints made. So anyway, I suppose I best just save this stream for now, because they were 1 hour 47 minutes, so I'm just going to stop the stream, because there's not a lot going on right now. Anyway, Alan might be back later. Oh, I've got my let's see, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That I've got my duty cycle pretty well balanced right now. That is very, very good. Let's turn the coil off. Yeah, that's actually very, very balanced right now. I like that. Anyway, I'm going to end the stream. I'll talk later. Or come back later, whatever.